Shalini?
Ma'am?
Unmute principal ma, mute la irukku.
Okay. Okay, ma'am.
I was downloaded, but
Okay.
you know, you need to verify whether you are seeing my screen.
No, sir. You have to share. Have you shared, sir?
Yeah, I'm seeing that, but I could not. I have stored in my
Download.
one second. Just please.
Sir, or else shall I share the screen share?
Sir, can we share from our side, sir?
Sir, we will share, sir. Principal, sir.
I think Malathi, you can go ahead with that plan. Plan B.
Okay, sir. We will share the PowerPoint, sir. Then you please inaugurate, sir.
Yeah, that's better.
Dear participants, so I welcome you all for a session 3 of IISc sponsored Digital Transformation Trends in Construction Industry. So it is my immense pleasure and proud to inform Department of Civil Engineering, Sona College of Technology has launching a book on title Digital Construction, which includes many technology through virtually. So I'll ask HOD ma'am and principal sir to speak about few lines about this book.
Dear participants, as I... Yes, sir.
Malati, please go.
As I mentioned in the morning inaugural session, we are into this digital construction platform and the technologies for the past 4 years. And we have implemented many projects also by the students, and also we have done some consultancy work on drones also. So with that experience, we thought of launching a book on digital construction, and which will elaborate the technologies involved in this digital construction. So our principal also one of the contributor of this book, digital construction book. So I would like to welcome our principal to launch this book today because all the participants are there in front of you. Our principal will launch that.
Yeah, Malati, it's a great honor for me to launch this book today. And
Okay.
need of the day, that's what I was talking. Are you able to hear me, Dr. Malati?
Yes, sir. Yes, sir. We are able to hear
I'm sorry,
you, sir.
Yeah, in between I am taking up this call, and I'm really, happy to be a part of, this book, and I should congratulate all the people under the leadership of Dr. Malati. Those who have contributed for, this book today. And I'm confident that this will be very much useful for the people, those who are looking for, kind of knowledge in the area of, digital construction. So I believe this is going to be really useful for every one of such kind of personalities. So once again, I congratulate all the members, who have contributed for the publication of this particular book, and it is going to be available in Amazon. And those who are interested, I think it is possible for them to get it, from through Amazon. And I believe Dr. Malati will tell you all, how exactly this can be taken a copy, and it will be one of the interested people. So I'm glad to,
Thank you, sir. Thank you, sir. Bhushan Taj, sir will inaugurate now.
yeah, virtual environment.
Yes, sir. Thank you, sir.
Great, great. So this is also done digitally. Congratulations to all.
Yes, sir.
Thank you very much for the video. Go ahead.
A small video clip on this book, digital construction now. Please share, Dr. Bhushan Taj.
Shalini ma'am, it's audible, ma'am?
Yes, yes.
Okay, ma'am.
Yeah, it's audible.
Okay, thank you so much, the contributors of this book from Civil Engineering Department, Sona College, and thanks to Dr. Gulshan Taj for arranging this wonderful virtual launching of the book. Thank you, sir, our principal sir, for being with us for launching this book on this auspicious day, sir.
Thank you, everybody. Thank you. All the best.
Thank you, sir.
Ma'am, can we start the session now, ma'am? Ma'am, Pooja, ma'am. Ma'am, Pooja, ma'am, can you hear me, ma'am?
Yes, I can hear you.
Okay, ma'am. Ma'am, are you ready, ma'am? Can we start after a small introduction?
Sure, definitely.
Okay.
It is a great honor for me to introduce and welcome the chief guest of the third section today, Ms.Pooja Yogesha, ma'am. She surely requires any introductions, but I would also like to enhance short introduction here. She is a master graduate in civil engineering from Politecnico di Milano, Italy, and she is well known for her work in the field of structural engineering and interacting with the international forum on day-to-day basis. She has explored weight in contributing to the field of research in civil engineering through building information modeling and data analytics. A bit to make the world ecologically intelligent, her area of interest focused on resources, mobilizations, optimizing safeties and durabilities of buildings, and in providing real-time sustainable solutions, wherein integrations of rigorous knowledge of structural behaviors of building and a life assessment of buildings comes into depictions. And currently, she works as a research assistant in Indian Institute of Science, Bangalore, in nearby to this place. I have there are and due to time I end up here and I request Ms. Pooja Yogesha to take over the section. The future of robotics please.
Shalini, please unmute mute others. Welcome, Ms. Pooja Yogesha, Research Assistant, IISc, Bangalore. This is Malathi heading the Department of Civil Engineering. On behalf of Sona College of Technology, we welcome you for this session and happy that you have accepted our invitation and being with us today. Regarding robotics in construction industry, your session is going to enlighten us in this area also. Thank you for accepting our invitation and also welcome for this session.
Thank you so much for the introduction, ma'am. And I'm extremely obliged to be a part of this program as well, and of course, virtually. So, can I share the screen?
Ma'am, 1 second, ma'am.
Okay, sure, no problem.
Yes, ma'am, now you can share, ma'am.
Okay, I'm yet to get that option. I'm not able to share the screen now. It's showing me only meeting organizers and presenters can share.
Oh, yes, ma'am. Yes, ma'am. 1 second.
No problem.
Yes, ma'am. Now the option has changed, ma'am.
Yes. Thank you so much. Okay, are you able to see my screen?
Yes, ma'am. Please enlarge the screen, ma'am.
Okay, sure. Okay, so today I would be giving you a presentation on the future of robotics and construction sector for the upcoming 1 hour or 1 hour 15 minutes. So coming to the intent of today's webinar, This is in order to help us in understanding the basic terminologies used in technology, per se, data science, data learning, and more. So this would be a base for understanding robotics or any other innovations at a larger scale. So after understanding few terminologies, we would be looking into the trends in construction across the globe. Also the opportunities and challenges associated, and how we as a stakeholder or a researcher or a business person.
Future of robotics.
Participants, kindly don't disturb the session. Please mute yourself. Yes, ma'am, please go ahead, ma'am.
Okay, so after understanding few terminologies, we would be looking into the trends in construction across the globe, also the opportunities and challenges associated, and how we as a stakeholder or a researcher or a business person would be aligning these as our strengths and driving our industry towards future. So accepting the fact that construction industry hasn't been utilizing the fullest of the potential available in terms of the new technology and digitalization, this webinar would also be a step towards upgrading ourselves to other industries' evolvement as well. So, well, the content for today's webinar would go like this. So, firstly, introducing few terminologies associated with robotics, later on robotics and AI, robotics and construction, case study, and then shift to the modular construction and associated challenges. Okay, so in this particular slide, I'm going to clear a confusion, and I'm going to tell you what exactly the artificial intelligence means, and what exactly is machine learning, and what exactly is deep learning, and how do we use data science considering all this particular technology and work. So let's go ahead and let us just think. I'm also going to create some Venn diagrams here. So I hope my screen is visible to everyone, no?
Yes, ma'am, it's visible, ma'am.
Okay.
And we are still in the first page, first slide.
Okay. Okay, I'll just stop sharing and share it again, okay?
Okay.
Okay, now?
Ma'am, now it's in a fourth slide, ma'am, understanding terms.
Yeah. So I hope everyone is able to see, right?
Yes, ma'am. We can see it, but I could see that you click that F5 and it's in the presentation mode. But we can see your PowerPoint actually.
Okay, so basically the PowerPoint is visible, no?
Yeah.
PowerPoint is visible, ma'am. Please press F5.
It's actually not working. I don't know what's the problem.
Ma'am, you can stop sharing and you can click F5. When we are sharing, you can share that tab. The presentation tab you have to share if you're sharing that.
Yeah, actually I did the same.
Then you can have the full screen share.
One second, try doing it again. How about now?
Yes, ma'am. Very clear.
Now it's okay.
Okay. Thank you. I'm sorry for the technical. Just a moment. Okay. So in this particular slide, I'm going to clear a confusion and I'm going to tell you what exactly the artificial intelligence and other terms mean. And how do we use this data science considering all this particular technology and how do we work along with it. So let's go ahead and let us just think. I'm also going to create some Venn diagrams. So there are a few Venn diagrams that you can see on the slide. I'm sure you must have heard of AI applications, you have heard of AI engineers, the magnetic kind of positions that are available in our industry right now. So it basically helps us to enable the computer or the machine to think. Basically, that means without any human intervention, the machine will be able to take its own decision, like how we do without any other artificial mean. So with respect to AI, this is the final goal. So you're basically creating an AI application, for example, a self-driving car. That is an AI application which actually uses machine learning and deep learning within them is basically an AI application. So it does some kind of a task. So finally, this is the main goal. And I have to reach over here and create an AI app. So, and then I talk about machine learning. Machine learning is also a subset of AI. And what does this machine learning help us to do is, it provides us the statistical tools to explore the data. A simple definition might be it provides us some statistical tools to explore and understand about that particular data. So now when I talk about machine learning, you might ask, what is machine learning? We basically have three different kinds of different approaches in order to go through this machine learning. So three of them would be supervised machine learning, unsupervised machine learning, and reinforced machine learning. I'm sure you must have heard these three terms in machine learning more in common. So I'll also discuss about what exactly supervised machine learning is now. So and machine learning. Okay, so in the supervised machine learning, we already have a particular kind of data sets or data labels that are already there in the system. So basically, we know what the output would be, since we already know what the input is already. So I'll also discuss about exactly the supervised machine learning here. And then the second technique is also called as the unsupervised machine learning. And then again, the reinforcement learning, or it's also called as the semi-supervised machine learning. So let me give you a very good example of a supervised machine learning. So in case of a supervised machine learning, we'll be having some label data that already I told, some past data. And with the help of this kind of data, we will be actually able to do the prediction for the future or forecasting. So let me just give you a very good example. Suppose based on, let me just consider I have a human has a certain height and weight as two main features, and I want to classify whether that person is belonging to an obese category or whether he or she belongs to a fit category. So this is one of the kind of data that I'll be working on. So I'll create a model, train on that data, and with the help of these kind of data, I'll be actually creating a supervised machine learning model. So that basically means in case of supervised, we have the past data. So in this case, the output is already known. And then coming to the next kind of category, that is the unsupervised machine learning. Here, I'll be having some label or past data. That basically means in my data set, I will not know what is the output. So in this unsupervised machine learning, we will cluster the data. And when I say clustering, what exactly it does is that based on the similarity of the data, it will try to group that data together. And there is some mathematical concepts attached to each of this, like linear algebra or any other mathematical operation for a basic level. And now in case of a reinforcement learning, that is the third kind of machine learning that we'll be dealing with, what will happen is that some part of your data will be labeled and later on some part of the data will not be labeled. So that is why it's called semi supervised learning.
Pooja, I think your slide is not moving.
No, this is the only slide.
Okay.
Yeah. Okay, so the computer or the machine learning model learns slowly by seeing the past data, and it will be learning as soon as the new environment and new data will be coming up. Just like how we get accustomed to different kinds of environment and get adjusted to it. In the similar way, the computer also programs itself. So that is how the reinforced learning works. So I hope you understand this, and this is what we are actually doing over here. And the most important part is that we need to have data. It also provides some statistical tools to analyze, explore, and analyze the data. And this is the three different techniques that we basically have in machine learning. And the last third part, which is the deep learning, is again a subset of machine learning. Now, why did deep learning got created? So what scientists thought is that, can we make the machine learn like how we, with the help of human brain, actually try to learn things? So the main idea behind deep learning is to mimic the human brain. You know how human actually learn those concepts, right? So similarly, we are creating models over here, which is learning those things. So first of all, I'm actually using this concepts of machine learning, and the main goal is to derive an AI application. You know, by using this particular techniques, I want to create a model which will be a self-driving car, as I spoke previously. So that is a self-driving car, maybe an AI application. So now the question arises, where does the data science fit into this? Right now, data science is a technique which tries to apply all these particular things. That means all these techniques, that is basically machine learning, deep learning, and many more. Apart from that, it also uses some tools, some mathematical tools like statistics, you know, probability, linear algebra, a whole lot of different maps like differential calculus, and so on. So that's the basic difference between AI, ML, DL, and DS that I mentioned here. So coming to the difference between artificial and intelligence and robotics, that has been, the talk of the town all over here in no matter which industry. So as a futurist, we try to help companies understand the latest technologies, trends, and artificial intelligence and robotics are both really important trends for companies to watch. But they're not the same. Sometimes people feel that there's an overlap between them. And in this slide, I want to explain what this is. So basically, artificial intelligence is an area of computer science that helps us to develop computer programs that can learn by themselves. So you either feed them data and they learn from this data, or you use sensors and input to help algorithms learn by themselves. So robotics, on the other hand, is a field of engineering. That is, they're basically focused on building and operating robots. So mechanical tools that can do things autonomously. So we have seen this in manufacturing for a very long time, where we have tools and robots that can build cars, but we also now have very advanced robots that can do almost anything. And this is where the overlap between these two fields comes in, that we now combine artificial intelligence and robotics, where basically the robot is the body and the artificial intelligence is the brain. So if you think about this, in the past, we have had robots for a long time building small things like cars and other stuffs, but have been dumb robots. They have picked something like spraying paint a car, but it couldn't really intelligently make any kind of decisions. So nowadays we can give those robots sensors, and we can give those robots things like cameras that act as their eyes. And we add artificial intelligence to this question as a brain. And suddenly you have a artificially intelligent robot. And this is where all the advances have come from in the robotics recently. So if you have about I think you have all seen a drone. For example, as a robot, the brain, the artificial intelligence makes this drone fly autonomously. So we now have self-driving cars again, combining robotics and the brain, the AI. So a really good example is a raspberry picking robot. This is something I've looked at recently, and basically in the past, it would have been impossible for a robot to pick raspberries. If you think about those delicate food, and every bush looks different, the location of the raspberry is different. How to gently pick it? And people basically felt that you needed humans with their dexterity to do this. And however, by now combining artificial intelligence and robots, you cannot achieve that. You now have a raspberry picking robot that uses machine vision or a camera to detect where the raspberries are, and then uses an arm, a robotic arm with lots of sensors in them, to then pick the raspberry perfectly. Not to push it too hard and then place it somewhere in a container to have it harvested. And this for me is a really good illustration of how far autonomous robots have now come. And basically, we now also have the ability of what we call reinforcement learning that I was explaining you in the previous slide. So instead of feeding a machine with lots and lots of data to recognize a raspberry, you let the machine learn things by experience. So we can use reinforcement learning. This is almost learning by experience. So I have recently seen a robot that is basically monitoring the environment, that is learning by itself to start to walk. And this each failure reinforces learning point each success. If this was a successful step and the robot, for example, I didn't follow over it, then registers this. So you now get the self-perpetuating learning cycle where robots can learn almost anything like infants do, like things like speaking and walking to start. And this is for me is the latest evolution of these of combining AI and robotics. So to recap, they're not the same. AI and robotics are not the same, but there are a fine line of differences between each of it. So AI is basically about the data and science is about computer programs that learn by themselves. Robots are about machines that can do autonomous things, but by combining them, AI becomes the brain. The robot becomes the body and you can achieve things amazingly. So that was basically about the AI and robotics together to be foreseen as our future. Similarly, there could be various other combinations that are possible, which are evolving in various industries and at various dimensions. So it could be AI and robotics together, AI and IoT, IoT and robotics. So many other combinations are possible. So these are all according to the industrial needs and according to the concerned projects and according to the specific project needs as well. So, but all these combinations have fine lines between each other in order to be evolved as well. And that was more on the side of technology and innovation. So coming to the construction and robotics part. So here, since we have already looked into different terms, now we'll be speaking more on this with respect to our industry, that is construction. So robot is a machine that is designed to execute the work automatically with speed and precision. So with the introduction of robotics technology in the construction industry, it provides many advantages for the companies and workers as it provides the efficiency of work, increases the productivity, and tasks are done much faster with the help of these kind of robots. Robots are also transforming the construction industry in a positive way with the dangerous and highly repetitive tasks being perished in the new technologies. There will also be very less labor required using new robotic technologies, which will help prevent some major injuries and casualties on site. Also, in Australia, according to the Safe Work Australia, construction is third in relation to work fatalities in the past 10 years. And according to the recent study showed that only 20 deaths in 2019 alone. So with the help of the new robotic technologies that they have adopted, doing the hard and risky task, there will be less injuries and deaths in construction. So wherein the safety is being the basic priority. So project managers can also benefit from the construction robots by having a better overview of the project. A few examples of robotics which are already deployed in the construction industry will be discussed in the following slides. An automated construction industry would also allow the practicality of the environmental urban development throughout the optimization of practices in terms of energy use, number of commutes, and waste generation as well. So to achieve all this, the construction firms need to have skilled employees in the field of IT and computer programming. A robot is essentially composed of two parts. Okay, so one is software and the other one is hardware, each requiring different set of skills. So breaking down these two general skills into subcategories of hardware and software that you can see on the screen. So in terms of software skills, the value of web design becomes significant once the trending international project delivery has gained attention. So this allows communication of different sectors and contractors within a firm to be facilitated instantly whenever the extraction or access to data is needed. not only for international project delivery, but even in the local level, a web-based communication system allows the faster and more accurate delivery of information to and from the construction site. And also data science as the other important factor, uh, which requires more attention in this field, which provides a foundation for prediction of the market direction. So data scientists are able to form and spread the data based on the existing data classifications. So to be more clear, data science is able to address the uncertainties based on the statistical models from the data obtained on the net. A well-established construction firm in the modern environment must be able to mine or extract a set of targeted data which would ultimately satisfy its objectives. So data after mining and processing will be sent via an established path to the consumer or the contractor. So it might be of a special consideration in some cases that the access to data must be limited to a certain level of authorities inside a firm. So that comes under other privacy issues. So the web service system is usually usually a system in such a way that the sender will deposit a set of data on a centralized server or pool, and the receiver or the consumer, whatever we call, will request the server for data delivery. So the server is normally available for public access. In such cases, an encrypted data set will prohibit unauthorized consumers to gain access. So simply explaining, the encrypted data is stored in a locked package and the key is in the hand of the consumer. So from the hardware part of view, so however, the story is relatively very different. So the data or software outputs are commands received by the actual machine itself. So the relation between data and machine is similar to the relation between brain and muscle. So here wireless communication routers are electronic devices that are sending and receiving the data based on the voltage or current differences in the module. So as the machineries in the construction are playing an important role, the robotic arms are those which require a high level of knowledge in the mechanical domain. So on the other slide of the flip, since data is sent in the form of DC or AC voltage packages, a decent robot active in construction is a combination of mechanics and electronics as well. So thus it indicates the requirement for having electronic skills employed within the modern construction firm. So overall, the maintenance of the construction machineries has always been costly measure amongst the. So such skills can actually help us reducing these costs as well. So some of the robots used in the construction industry are shown here. So first one is the rebar tying robot. So with the introduction of rebar tying robots, the work will be more faster than humans, and it actually reduces the cost. So rebar tying robot are also called as tie-bot, is a new smart and advanced developed robot that can identify every section of rebar on a bridge that can tie it and move it to the next section. So the robot can do almost the work. All that is required is for few workers is to place the rebar and oversee the route's progress. So rebar tying is also a painful job for humans that have done rebar typing and has led to strains and injuries from the type of construction work. So again, the second photo that you see on the screen is the automated demolition robots. So one of the most dangerous jobs in construction is demolition work, which has been proven very unsafe for the workers. So things can happen unplanned, like the structure collapsing or causing a damage. So thankfully, one of the latest innovations in this construction robotics that is used for demolition is the Husqvarna. I'm sorry for the pronunciation if it's wrong. So the automated demolition robot can demolish entire building sites as well as fit into small areas that construction workers often struggle to reach. So the automated demolition robot is expected to worth around 320 million in 5 years. Automated demolition robot is a promising area of growth and an area of innovation that construction companies are looking forward in future. So although the demolition robot can take time to bring in the demolition team to do it manually, However, it can significantly reduce the risk of OH&S and cost, which is a huge bonus for the construction industry. And the third one that you can see is the artificial intelligence for construction mapping. So sorry, the photo is not here. So on-site progress is one of the time-consuming and hard job to monitor for construction managers, especially if it's a very big construction site. So however, with the help of Doxel technology time tracking, so more efficient by using drones and rovers to map the construction sites every day. Then they use these photos taken by the drones to compare it with the 3D drawings. So BIM models and the project timelines to see if the project is in progress. So this also increases the accountability when it comes to the on-site progress monitoring. So from the data collected, areas that are falling behind or different to the models that can be identified. So project managers can see the problem either and fix the defect and track the project timelines and is on the budget or not. So that is the third one. And the fourth one is the bricklaying robots. So this is one of the latest promising innovation in construction, also known as SAM, that is semi-automated mason. So this bricklaying robot uses its mechanical arms, can pick up bricks, cover them with mortar, and lace each brick perfectly. So the only thing that is required for the workers is to load the machine with bricks and clean any extra mortar. So the bricklaying motor that is, the robot that is SAM can lay around like 300 to 400 bricks per hour, easily 5 times more than the workers who could roughly lay 60 to 75 bricks an hour. So which shows there is more productivity and reduces budgets on projects. So it can also free up workers' time to focus on more complex tasks that are better done with humans. And also the other picture which shows the 3D printing robot that the same about the same information. There was a session also done in the second half of today's program. So I think most of you would be much aware about this technology because sir enlightened it with every small and very detailed point of view. So this is another technology that is having a huge effect in the 3D printing, which is used for design and architectures. A mobile robotic arm controls the 3D printer and sets the program through instruction. So the first 3D printer bridge was built in Netherlands, and there are also other 3D robots that can be built an entire building that's structurally safe. So with the continuous improvement of new robotic technologies, there will be more and more building built through automated building processes, which will improve the productivity of the project with lesser cost. So again, the other one is the welding arm. So this is one of the most advanced technologies as well that has been developed in robotics welding. So the robotic welding uses its mechanized arms, welding positioners, and robot controllers to weld quickly and accurately. So robotic welding only requires only a few workers to oversee the work. So with the use of robotic welding, there will be very less risk of injuries and no need for the manpower to be used on manual tasks. So with the help of these kind of robotic welding technology, project teams can actually focus on more important tasks so they can meet the timelines or deadlines or any milestones that they're planning to reach, and also managing the budget and ensuring the productivity of the whole team. And coming to the last one, that is the autonomous construction machineries. So these are some of the built robotics which has been developed. A new bulldozer that self-drives during the earthworks. So the self-driving bulldozer can automatically move piles of dirt from one destination to another without any supervision. So the bulldozer uses its sensor and self-driving technology to grade earth on construction site without the help of any worker on site. So this can help free up team to do the more important tasks that require more skills. So the other studies are also showed an emphasis on the benefits of utilizing the automation and construction for extraterrestrial applications, and also has evaluated the gains achieved in managerial terms as well. So, well, now that I have explained the robots and robotics in construction, but root of the question still remains, that is, why these trends? There are many people who are already ready to adopt the upcoming trends and innovations followed in construction industry. But also not to forget that there are a few others with silos mentality who do not want to go with a new technology and trends as they're on a higher end in terms of cost or the skill labors involved or the accountability or many more aspects like that. So in order to address that issue, this is why of the problem that we are working on. So I'm showing a real demonstration and cost analysis of a 3D painting adopted to paint a building. So more about the building, it would be like a it is a residential building in Kukatpalli, Hyderabad, Telangana, India. So also has been considered for the application of robotics in building construction. So in this case study, the robotics is applied only for the plastering case. So the study has been done by comparing the cost and time of the work done. So that is for the plastering by the conventional method and also with the project with the robot which projected values of cost and time, and the summary of cost is shown in this slide. So you can see that OPEX 62% is saved in the cost and also 88% is saved in time. So this addresses the main issue of why this kind of technologies that are important in the current construction project. So and then again one more root question that would again be unanswered is, so why are companies and stakeholders adopting robotics in construction? So a main reason being a shift to modular construction of various types. So again, according to the needs of project as well. So what do you mean by a modular construction? So modular construction is nothing but the ability to manufacture in different place and transport to the place of installation in one or more sections. So modular coordination in the building becomes increasingly popular through countries which are located in geographically remote and cold areas such as Sweden and northern Canada, or where the feasibility of on-site construction is very low. So this kind of a construction was introduced to European and North American countries after World War II. So reports in 1996 actually shows that there were higher precast levels in Denmark, Netherlands, Sweden, and Germany. So they were all the cold countries and which were a bit remotely located. So in the early 1970s, Eastern and Western Europe also started using this kind of methodology for construction of their new suburbs, towns, and public buildings. So that's why they set up specific standards for examining component specifications such as tolerance and installation standards as well. So because of this high demand and lower cost, this industry has become popular in Asian countries like Malaysia and our country, that is India as well. So the main reasons for this widespread adoption of modular construction is simple. The 4 points that are being shown in the screen. So geographically remote and cold regions, low feasibility of on-site construction, and also government policies collaboration. So there are some reports according to Singapore country wherein they have made it they have included all these policies related to construction to be mandatorily adopted in Singapore. So that's why Singapore, construction industry is evolving more than any other country. And also people who are following the norm, who are going with the change in the construction trends and following the new trends that's been coming up. So on coming to the various levels at which the concept of modularity has been worked on, so it can be categorized into following different sections. So manufacturing and construction, prefab construction, standardization and pre-assembly, offsite construction, and modern methods of construction. So these are some of the most common used terminologies used in the literatures to describe the offsite construction. So offsite construction adoption is influenced by many of the factors. So the type of the project and the construction application, and some of the major application of offsite have been the areas of public or social housing, private housing, offices, hospitals, and many more. So according to the same, there are different kinds of systems that are being introduced in different countries related to framing systems, volumetric modular building, cladding systems, baths, toilet or kitchen pots, building services, and many panelized kind of construction system. So these are some, the screen that you can see are different kinds of categories of modular construction that has been in trend nowadays and has been there in trend from a pretty long time. So coming to the first part is the component manufacture and sub-assembly. As the definition almost says that the items have already been made in the factory and they never consider it for on-site production. So the non-volumetric and volumetric pre-assembly, again, which does not enclose any usable space, and then also which includes the usable space and are typically fully factory finished internally and externally as well. So there are also modular system and hybrid system, and of course the structural configurations also change according to the different levels that have been shown here. So that's why there is a major shift in the modular construction nowadays. So though there are many number of benefits from the manufacturing associated with the construction, there has also been advantages of this offsite techniques in terms of time, quality, cost, productivity, power, manpower, and process. Further, they have also documented major benefits as speed of construction, higher quality, lower cost, increased certainty, and many more. So, and also they have also simplified the construction processes. However, the implementation or adoption decision of offsite is influenced by factors such as location, land use, density, volume, user needs, and many other environmental conditions. So, though there are benefits of offsite construction, the trend of offsite take up and construction is different in different countries. Though prefabrication is not a new technology, the application, drivers, and consequences are to be explored from a perception of current expertise and management practices, as this differs from each country to country. And since India is a huge country with different demographics that is changing from kilometers to kilometers, so we need to look into all these different aspects while considering robotics in construction field or trying to optimize or construction processes. So so these were investigated throughout for the various factors, and after a thorough review of the literatures, some of the articles were identified that there are presented a range of issues under drivers and barriers as well. So there are different challenges that are associated with the robotics and construction. So one is the difficult climatic conditions that would involve the exposure to dust, calibration in relation to environment, adjustment to changing surface conditions, complexity of the working environment. So sometimes, there will be a very huge, large scale project that would be involved, and sometimes a very small scale project. So robotics cannot be used for all kind of projects. It also depends on how the project needs are and how the budget or timing of the project is particularly scheduled. And coming to the environmental conditions of these projects, so different buildings, there are different kinds of materials that are being used in different buildings, and also there are many environmental impacts also for the same. So that is also one of the factors that we have to remember while considering robotics and construction. So adjustment to changing surface conditions, sometimes it's very cold in some places and sometimes very humid, so there's always a shift of weather conditions from time to time. So in order to uh, uh, make sure that the materials used or the parts that are being completely used for the modules, these kind of materials should be subjected, should be able to customize each other for the weather condition that's been changing as well. And also there will be a different working environment in different kinds of companies that have been working, sometimes private, sometimes government. So there is always a complexity involved. So until and unless a good workflow is been revised, so it's very difficult to adopt such kind of a construction practices as well. And some changes in the nature of the robotized work process versus the traditional human performed work process. So there could be real time problems. So per se that we want to monitor the on-site progress, like how is the on-site progress is going on while sitting in a particular laboratory. So you keep some cameras fixed there and then you try to monitor. So sometimes there will be calibration problems, so you don't get the real time prediction, like there would be some lag or delay because of technical errors of the computer. So that could also be some of the technical challenges or the real time problems that would be associated. And one more thing would be the identification of various types of objects in natural environmental conditions. And again, the interactivity between sensors and end tools. So this is also related to the real time problems. So that is all. So I can say that all these are interrelated to each other. So the primary contribution of automation in construction is the development of a comprehensive multidimensional analysis of costs and benefits associated with a specific robotic application. So it is quite important to analyze the success through the technical and economic feasibility. So the technical feasibility is determined by an economic evaluation of individual steps that are being taken to accomplish the given work task, and by analysis of the requirements for the robot control and process monitoring. So the economic feasibility, which is perceived to be the decisive factor in the market success of the proposed robotic systems, is determined by the analysis of the costs and benefits associated with the development and field implementation. So specific technologically challenging process and characteristics of robot construction appliances all include these kind of factors. So in contrast, I can say that a robotic system that would operate with no need for detailed pre-planning would be less technologically demanding and may therefore be, easily developed during early stages of robotics integration into the construction field. Also, the sense and act process that can probably eliminate the need for high accuracy when positioning the robot at its workstation, a fact that that saves the time and leads to greater economic feasibility of the system. So some of the researchers, attempted to increase the autonomy level of these robots by enabling them to map their environments and independently, navigate through them. Although construction sites are characterized by inaccurate geometries, numerous obstacles, and the mapping and the navigation methods may be adopted to it. So such navigation methods are expected to deal with these difficulties and succeed in achieving accurate enough results. So researchers and developers of autonomous robots have attempted to solve the problem of adjusting the robot to its environment by developing an automatic mapping and self-positioning systems. So the robot then autonomously navigates from one workstation to another. So the problem of difficulty in climatic conditions can be resolved by this one of the possible solution. So again, well, summarizing everything about this webinar could be the construction industry has a lot of opportunities in developing tools and technologies in order to speed up the process, policies, technology, and workflows. But until and unless there's a shift from the industry's mindset towards robotics and innovation, the gap between the opportunities and the challenges can never be brought closer. So also it is very important to realize the need of the heart in order to be competitive in this era and develop the new skill sets required for the same. Also, there are many, if people are looking on to develop new skill sets in terms of AI and robotics, the one of the solutions that are available online is the Google Collaboratory, so that you can try working on different Python programming and try to learn basic things from them and try to apply all these kind of Python programming into artificial intelligence that we are looking forward to construction monitoring. So this is all from my end, and thanks a lot for giving me this opportunity. So you can, I'm open for any questions. Thank you. Okay, I have this question from Gulshan Taj, that what will be the success rate in country like India? So, well, that's a very thought-provoking question. So thank you for bringing this question into discussion, Gulshan. So basically, the success rate in country like India, it actually depends on the project itself. So I can't say a particular number because that there are different kinds of projects that's been happening, and there's no particular percentage. So I can just tell it between 15 to 25% maybe, according to what I have learned and looked into different literature. I hope I addressed that question. Okay, so there's one more question from Anusha. So, is this technique helpful in Indian economy? So that's the basic question that I had addressed in my presentations. So again, it depends on the institution rules and regulations that people want to get this kind of technology into picture. So that is one of the challenges also involved in robotics and construction. Of course, there are new startups that are coming up. One of them is in Hyderabad, I saw, is for painting the walls. So that is also, there are few small scale level of startups that are been coming up in order to get these kind of technologies into pitch of the construction industry. I hope that I addressed that question. Thank you, Anusha. So, can you cite some examples wherein this technology has been implemented? Success rate. Okay, there have been many projects. So one of the projects that we had seen is by the professor himself was explaining about the 3D printing that has been used in IIT Madras in the morning session. So that could be a very good example for adopting this kind of a technology. And there's one new startup that has been come up in the Hyderabad. So that's basically on the painting the wall. So that's one more. And there are some metro stations that are trying to use this real time kind of technology in order to address, get a bit inclined towards robotics. What is futures of robotics in industry? Bhaskar, thank you for this question, but in which kind of industry, like construction or? Okay, so future for the construction would be, so the basically in Indian projects, if we have 20 to 25% of project delay, it is acceptable. So if we try to try to decrease this percentage in order to evaluate a project progress, then somewhere this technology and implementation of robotics in this particular kind of industry can be very helpful, I could say that. And the future of robotics, we can see it in 10 to 15 years, I can say, but not very close. And if we look up to bring this gap closer between 2021 and 2035, so only thing would be the government policies that are involved in construction practices. So if that has been mandated, then the future of robotics and construction industry can actually be evolved when compared to other industries. So that is where we are lagging in when compared to the other industries. And also an add-on to this is when we are trying to bring in more trends and innovations, we have to see the other side of the picture, like political, economical influence on countries' GDP. So there are many number of people in our country, so that is one more factor. So the job opportunities might decrease, and that could be an hindrance to the robotics in our country. Okay, any other questions?
Ma'am, one more question is there. Exoskeleton and robots are same.
Exoskeletons and robots are same. I can just tell that there could be a minute different. I mean, a line. a finite difference between these two. So robots, considering, how do I tell it? What? Hello, am I audible?
Yes. Yes, ma'am.
Hello.
Ma'am, yes, ma'am. You are audible, ma'am. Ma'am, Pooja,
Hello.
ma'am.
Hello.
Ma'am, you are audible, ma'am.
Actually, I'm losing. Hello.
Hello, ma'am. Ma'am, it's audible, ma'am.
Okay, 1 second. I'll try to join again. 1 second. Hello.
Ma'am, ma'am, now is it audible, ma'am?
Yeah.
Yeah.
Okay. So getting back to the question. Okay, so exoskeletons and robots are same. Sometimes, it could be taken as same, and sometimes it can be different according to the structural aspects. And when we are looking into the large number of forces or speeds that are involved during manufacturing. So there is a difference. I don't say that those two are same, but there are few arguments regarding this particular aspect when different research papers that I've gone through. But most of it says that these two are two different elements. So if the task is very structured and requires very large forces or speeds, which involves the auto manufacturing, then the robots are actually great. So if this task is very ambiguous and requires lots of manipulation, planning, and perception, so in general construction, then we would actually look out for exoskeleton. So one more thing from it's this is from Divyashri Yadav. So what steps we can follow to learn implementation of AI or robotics in our academic projects practically? Okay. So in order, I would address this issue in various steps. So first thing is we need to do a lot of research regarding the implementation of AI or robotics in our academic projects practically. So first we need to look into the areas that we are looking forward to implement AI in the projects that we are working. And then we need to find different papers or research areas that are something related to which are related to the same. And then we need to find that research gap between these two and try to implement these kind of robotics construction techniques in our project. So that is one base work. So one more implementation of AI could be upgrading our skill sets. So when it comes to our different industries, we see that construction industry is somewhere getting more people from IT professionals and electronics. So we shouldn't restrict ourselves to only civil engineering or construction industry, rather see it in a bigger or wider picture. So taking up grading our skill sets is very important, because we need to be competent enough to according to the different industry needs that's been coming up. So that is also one of the most important thing. And awareness, very important. So we should be aware of every other different technologies that are coming up, and also the steps that have been involved in order to adopt those kind of technologies. So it also depends on what kind of implementation that you would like to do. So it could be in different kinds of aspects like technologies, policies, processes. So for everything, we need to do a comprehensive work, try to make our workflows proper in order to adopt those kind of projects in practical. I hope I addressed that question, Divyashri. Thank you so much for the question.
Any other question from participants?
Okay, so Divyashri says that multidisciplinary knowledge is very important in this case. Very true, but also we need to be very specific about what kind of a multidisciplinary knowledge that we are going to address or our research area of interest would be. All right, so any other questions?
Good afternoon, madam.
Good afternoon.
I'm this Christian from Knowledge Institute of Technology, working as assistant professor. I have one query, ma'am.
Okay, sir.
Ma'am, whether this AI incorporating with machine learning is possible with structural health monitoring, ma'am?
Definitely, sir. So actually, machine learning is a subset of AI. Okay.
Yes,
So
madam.
there are been many researchers have been working on structural health monitoring of particular structures, but more in other countries like Canada and other cold countries, because that is wherein there is a change in climatic conditions. So that is where the structural health monitoring is very important. But the level of corrosion in any particular buildings, but that is a very hard part, because moisture, the characteristic of a moisture in buildings, it varies, and the many available non-destructive testing that are
Yes.
used is also very difficult in order to analyze those moisture component of a building. So that is one of the areas the research has been going on, but it's bit challenging as well. So that is one of the most important structural health monitoring
Yes, ma'am.
research that's going on.
Ma'am. I want to know what kind of a mini project can be given to students in these areas. Can you suggest few areas or topic so that we can take an initiative to do some projects in that area, ma'am? Say, for example, in bridges, nowadays, apart from non-destructive technique, we can use some light emitting sensors. Thereby, we can detect the crack location instead of manual eye inspection. We can use of optical cables. So, likewise, is it any possible to do with the AI? As like an example of Google AI, Google AI can sense the eye, and it can fairly advancedly inform the any problem in the health. It is released by the Google CEO. So likewise, any possible ways in crack detection? That's what I'm asking. Any projects, mini projects, health
Okay, so
monitoring aspect.
yeah, so one thing is cracks detection. So again, we need to feed the system. I mean, train the system with different kinds of cracks that could be possible. So analyzing that with a dummy data of set could be done. So that could also be one of the many projects. But again, installing cameras and monitoring it, and where to install those cameras, provided how the construction of the building is also one more thing. So if these kind of small aspects are looked into, then clearly that could be one of the many projects associated with cracks in buildings. And one more thing would be having some cameras near the construction site and seeing how many labors are on site. So there, the movements that are being recorded for robotics can be programmed in Python, that is the open collab that is already available. So small different programs could be there, and this could be connected with the camera sensors that are being put on the site, and similar kind of calibration can be done, sir.
Okay, thank you, ma'am. Thank you for the
Yes, sir.
opportunity.
Thank you so much for the question. Yeah.
Ma'am, I think the question was over, ma'am. Ma'am, do you have any question and answer session for the participants?
Can I mail it to you regarding the same?
Yes, ma'am.
Okay. Thank you so much for the opportunity given, and it was nice interacting with many different people here with a different set of knowledge and everything. Thank you so much.
Thank you, ma'am. Thank you for your patience in clearing all the participants' doubt, ma'am. And also, I personally thank for accepting my invitation as a speaker very immediately. And you have elaborately explained the new technology with clear pictures and how the future of construction going to be using a robotics, ma'am. Once again, thank you so much, ma'am. Have a nice day.
Thank you so much. My pleasure. Bye-bye.
Thank you, ma'am. Bye, ma'am. Participants, please wait. We will post the feedback link here. Please see the chat box. Feedback link is there for day 1. Kindly fill it. Feedback link for day 1 is posted in the chat box. Kindly fill the feedback form. Also, the attendance was downloaded for all the 3 sessions. The link was posted in our WhatsApp group also. After completing the feedback, we can leave. Thank you all. Thank you all for attending and making the day 1 program successfully. We will meet tomorrow by 9:30 a.m. So tomorrow's speakers are Dr. Amarnath sir and Dr. S.K. Singh and Dr. Ajay Chaurasia sir from different industry. Thank you all. Hello, ma'am. இல்லைங்க மேம் அவ்வளோதாங்க மேம் 3:30 அவ்வளோதாங்க மேம் ஓகே மேம் தேங்க்யூ Thank you all. Kindly fill the feedback and then leave the session, please.